Question number 8. In which of the cases depression freezing point is equal to the cryoscopy constant for water? A, 0.6% by mass of urea in aqueous solution. B, 100 grams of sucrose in 100 ml of solution. C, 9 grams of glucose in 59 grams of aqueous solution. And D, 1 molar KCl solution. All right, let me first explain what is the exact correct answer. The actual correct answer is the option C. Okay, now, why is it exactly the option C? We will understand it in due course of time. All right, so let's start with the entire scenario. Now, when we start with this, first thing is, of course, I'm going to take into consideration of delta. TF is equal to KF. Why did I take this? Is because I wanted to understand about the cryoscopy constant. Cryoscopy constant is nothing more than the depression in freezing point constant. All right, so therefore, now, if this is a case that we have taken into consideration for 9 grams of glucose in 59 grams of aqueous solution, right? So in the aqueous solution, now therefore we are going to have, first thing, the amount of solvent. Therefore, calculating the amount of solvent, that is going to be the solution of glucose 59 grams minus 9 grams, that is the glucose what we have added. That means 50 grams is the amount of solvent. This is the first thing that we need to understand, right? So therefore, now next point is, we'll continue with respect to the molality. So therefore, for molality, that is, how many number of moles of solute that we have in the weight of solvent. Okay. Now, let's take this entire case. Over here. Therefore, first we shall calculate the number of moles so that we can find out the molality. So, number of moles. Okay, of solute, of course, glucose. So, that is for the glucose. Moles that we have is how many we are using. What is the weight? Weight over molecular weight, correct? So now if we are finding out how much weight did we use over here, 9 grams. All right, so 9 grams divided by, okay, 180. Let me keep it as it is. Okay, molecular weight of glucose is 180. So therefore, now let's take this particular thing to the directly as a number of moles. It will be very easy to calculate. So molality is equal to the number of moles are 9 by 180. The whole thing divided by, now weight of solvent, that is 50. Okay, 50 over 1000. Okay, because we need to calculate in the form of for kgs. So this is for kg in the form of kg. All right, so into kf. Now into kf. Okay, so into kf, and that is going to give us a delta t. Okay, into kf, if I multiply, it's going to give me a delta tf. So therefore, let's continue this further. Now, so 9 by 180 into 1000 over 50. Okay, now for, of course, multiplied by kf is going to give me a value of delta tf. Now, let's cancel out the terms. 1 over here, 1 over here. These terms get cancelled. So 5 ones or 5 twos, 2 ones, 9 times, right? So therefore, what we are going to have is 1. So therefore, in this entire scenario, it's quite ideal to say that when we are taking 9 grams of glucose, Okay, so it is giving me 1 into delta, 1 into Kf is equal to delta Tf. That means delta Tf is becoming equal to Kf, deprivation in freezing point. Okay, so in this case, the depression in freezing point is becoming equal to the cryoscopy constant. Now, let's try to understand the other aspects. Now, if I take over here, the number of moles increases and therefore the depression in freezing point occurs. So therefore, that value surpasses the value of Kf. Okay, so the same goes true with any of these particular aspects, right? So therefore, the answer over here is the option C. So therefore, option C serves to be a perfect answer.